Three laureates share this year's Nobel Prize in Physics for their studies of complex phenomena. Shigeru Manabe and Klaus Hazelman laid the foundation of a knowledge of the Earth's climate and how humanity influences it. Giorgio Parisi is rewarded for his revolutionary contributions to the theory of disordered and random phenomena. Shigeru Manabe was the pioneer of the research. In the 1950s, Japanese atmospheric physicist Shigeru Manabe was one of the young and talented researchers in Tokyo who left Japan, which was been devastated by war, and continued their careers in the US. In 1960s, Manabe's led work on the development of physical models to incorporate the vertical transport of air masses due to convection as well as latent heat of water vapor. To make these calculations manageable, he chose to reduce the model to one dimension, a vertical column 40 kilometers up into the atmosphere. Even so, it took hundreds of valuable computing hours. He found the oxygen and nitrogen had negligible effects on surface temperature, while carbon dioxide had a clear impact. When the level of carbon dioxide doubled, global temperature increased by over 2 degrees centigrade. The model confirmed that this heating really was due to the increase in carbon dioxide, because it predicted rising temperatures closer to the ground while the upper atmosphere got colder. If variations in solar radiation were responsible for the increase in temperature, instead, the entire atmosphere should have been heating at the same time. How can we produce reliable climate models for several decades into the future, despite weather being a classical example of chaotic system? Around 1980, Klaus Hazelman demonstrated how chaotically changing weather phenomena can be described as rapidly changing noise, thus placing long-term climate forecast on a firm scientific foundation. Furthermore, he developed methods for identifying human impact on the observed global temperature. As a young doctorate student in physics in Hamburg, Germany in 1950s, Hazelman worked on fluid dynamics, then began to develop observations and theoretical models for ocean waves and currents. He moved to California and continued with oceanography. Obtaining a climate model from noisy weather data can be illustrated by walking a dog. The dog runs up the lead backwards and forwards, side to side and around your legs. How can you use the dog's traces to see whether you are walking or standing still, or whether you are walking quickly or slowly? The dog's tracks are the changes in the weather, and your work is the calculated climate. One additional difficulty is that the fluctuations that influence the climate are extremely variable over time. They may be rapid, such as in wind strength or air temperature, or very slow, such as melting ice sheets or warming oceans. For example, uniform heating by just 1 degree can take 1,000 years for the ocean, but just a few weeks for the atmosphere. Hazelman created a Skystick climate model, which means that chance is built into the model. His inspiration came from Albert Einstein's theory of Brownian motion, also called a random walk. Using this theory, Hazelman demonstrated that the rapidly changing atmosphere can actually cause slow variations in the ocean. Once the model for climate variations was finished, Hazelman developed methods for identifying human impact on climate system. He found that changes in solar radiation, volcanic particles, or levels of greenhouse gases don't have so large impact on climate change as the effect that humans have on the climate system. The model clearly saw an accelerating greenhouse effect since the mid-19th century. The levels of carbon dioxide in the atmosphere have increased by 40%. Earth's atmosphere has not contained this much carbon dioxide for hundreds of thousands of years. Accordingly, temperature of the Earth has heated up 1 degree centigrade over the past 150 years. Thus, Shigeru Manabe and Klaus Hazelman have contributed to the greatest benefit for humankind in the spirit of Alfred Nobel by providing a solid physical foundation for the knowledge of Earth's climate. Around 1980, Giorgio Parisi presented his discoveries about how apparently random phenomena are governed by hidden rules. His work is now considered to be among the most important contributions to the theory of complex systems. The particles in a gas can be regarded as tiny balls flying around at speeds that increase with higher temperatures. When the temperature drops or pressure increases, the balls first condense into a liquid and then into a solid. However, if the change happens rapidly, the balls may form an irregular pattern that doesn't change even if the liquid is further cooled or squeezed together. If the experiment is repeated, the balls will assume a new pattern despite the change happening in exactly the same way. Why are the results are different? However, the subject of Paris's original work was a different kind of system spin glass. This is a special type of metal alloy in which iron atoms, for example, are randomly mixed into a grid of copper atoms. They change the material's magnetic properties in a radical and very puzzling manner. Each iron atom behaves like a small magnet or spin which is affected by the other iron atoms close to it. In a spin glass, the spin points are frustrated. Some spin pairs want to point in the same direction and others in opposite. So how do they find the optimal orientation? In 1979, Parisi made a decisive breakthrough when he demonstrated how replica trick could be ingeniously used to solve a spin glass problem. He discovered a hidden structure in the replicas and found a way to describe it mathematically. It took many years for Parisi's solution to be proven mathematically correct. Since then, his method has been used in many disordered systems and become a cornerstone of the theory of complex systems. That's why the Royal Swedish Academy of Science has decided to award the Nobel Prize in Physics 2021 with one half jointly to Siguro Manabe, Klaus Hasselmann, and the other half to Giorgio Parisi. So if you find the video interesting, give a like, subscribe the channel, and as always, thanks for watching.